When you add an acid or a base to a buffered solution, first you have to figure out what part of the buffer is going to react with the substance added. If you add an acid, the basic part of the buffer will react, and vice versa. Then you're going to solve with stoichiometry until one of the reactants is used up. You have to have moles because they're reacting. Then, if you only have a strong acid or strong base left, then you can just use our pH equals negative log of H concentration, or POH is equal to negative log of OH concentration. If we have a buffer, we're going to use Henderson-Hasselbalch. And if we have a weak acid or weak base left, then we have to set up an ice table and solve. So first thing, label all of your pieces. NaOH is a strong base. We have acetic acid, which is a weak acid, and sodium acetate, which is a weak base. The base, the strong substance, which is a base, has to react with its opposite, which is an acid. We want to write a net ionic equation, so we're going to ignore the spectators, which would be sodium on both of these. So we have hydroxide ion is going to react with acetic acid. When they react, they produce water and acetate ion. If we had left the sodium in, then we would have had sodium acetate to end with. Sometimes, though, if you leave the spectators in, it gets more confusing, because had this said potassium acetate and we had sodium hydroxide, then people get confused because they don't see like where those would all fit in. So leaving out your spectator ions is going to make your life solving easier. Then we want moles. Well, our sodium hydroxide was given in moles. And the other was given in molarity, but it's 1 liter, so that is my moles. I have that of acetic acid, but I also have that of sodium acetate. Remember, sodium acetate is a salt, so it's got to show up in the product side in the initial part. Since we're solving with stoichiometry, this one's a strong base, this is a weak acid. They're going to keep reacting until one of them is used up. So the smaller one is going to be used up completely, so 0.01 minus 0.01, and this will be plus 0.01. I crossed out my water because water wouldn't be part of the equilibrium expression. So they fought into the death, so hydroxide is now gone. Then 0.5 minus 0.01 gives me 0.49 moles. And then 0.5 plus 0.01 is 0.51 moles. Make sure you always divide by total volume at the end, which gives us the same thing in this case, but it's a good practice to show that you're going back to molarity. So then always reassess. I have a weak acid and a weak base, so I now have a buffer. Since I have a buffer, I can use Henderson-Hasselbalch. I say my pH is equal to my pKa. Plus log of base. I have labeled that. My base is 0.51 and my acid is 0.49. Notice I have more base than acid, so my pH should be slightly greater than my pKa. Had I not had any sodium hydroxide, my original pH was 4.74. So notice the change in pH was it only increased by 0.02. So even though I added a strong base, pH was basically held constant because I had that buffered solution. I was able to neutralize the hydroxide without large changes in my buffer concentrations. So go ahead and pause the video, figure out who's going to react with which one, and write your equation. Restart when you have your equation written down. So HF is a weak acid, so this must be a weak base, and HCl is a strong acid. My spectator ions are chlorine and sodium. So hydrogen should react with a weak base to produce HF. So that should be the equation for this reaction. Now go ahead and pause the video and write your initial line. Restart when you have your initial line filled in. So I need to find my moles of each of my reactants and products. So I convert my milliliters to liters. Multiplying those, I get 0.004 moles of hydrogen. And my NaF and HF, I have 0.2 molarity and 100 milliliters. So 0.2 times 0.1 gives me 0.02. So now they're going to react. Looking at those, I only look at my reactants. 0.004 is smaller, so I'm going to subtract that amount from both of those. Then remember, I have to add that to my product side. That's why it's a good idea to have that line down the arrow just to make sure that you're adding on the product side. So that's 0. Now that I have my moles, I have to divide by volume. I divide by total volume. In this case, I had 4 milliliters and 100 milliliters. So that's 104 milliliters. So 0.104 liters. Notice that my amount of acid increased and my amount of base decreased because some of my base reacted with the acid. So I reassess. This one was my weak acid, this one is my weak base. I still have some of both left, so I still have a buffer, which means I can plug that into Henderson-Hasselbalch. My Ka, or my pKa, I'm going to go ahead and solve that up here, is 3.14. So 3.14 plus log of base over acid. It's another reason to label it, so then I can quickly look over here and be like, oh, my base is this one and my acid is the other one. Looking, I have more acid than base, so my pH should be less than my pKa. Plugging it in, I get 2.97, which is less than my pKa. If I wanted to calculate the change of pH, this would be my initial pH, because when I have equal amounts of acid and base, pH will equal pKa. And I had 0.2 of both of those, so that was my initial pH, and it went down to 2.97. Alright, here is our last one. Go ahead and pause the video and first write your equation, and then restart once you have your equation. So first, you should have labeled everything. And we have a strong base, so a strong base should react with our weak acid. We're going to ignore spectator sodium. So you should have had hydroxide reacting with HCN to produce cyanide and water. And we don't care about our water. So now go ahead and pause the video again. So now go ahead and pause the video and set up your table and react it and finish the problem. Restart when you're done. So we had 0.0032 moles of hydroxide and 0.026 moles of each of these. Our hydroxide was smaller. We divide by total volume in liters. And then in this problem, you needed the Ka. So the Ka was 3.98 times 10 to the negative 10th. So if you got that far and you got stuck, go and pause the video and keep going, calculating your pH. So your pKa should have been 9.40 plus log of base over acid. I have more base than acid, so my pH should be greater than pKa. And so my pH is 9.51.